Welcome to my channel. Here is Faraday's first law of electrolysis. I observe that some students find it difficult to solve questions regarding to relation aspects of questions that regard to first law of electrolysis, Faraday's first law. Now, in this video, I'll be giving you 4 almighty formulas that's capable of giving you your answers to any questions that regard to first law of electrolysis. So stick to this video as I give you the step-by-step of those formulas. Diving to this, the first question here is, what does Faraday's first law state? Yes, Faraday states that the mass of a substance that is being deposited during electrolysis is directly proportional to the quantity of charge that passed through it. The mass of a substance deposited through electrolysis is directly proportional to the quantity of charge, Q. Obviously, you know, quantity of charge is given as Q, quantity of electricity that passed through it. Then if that is so, remember that when you change sign of proportional to equality, you introduce a constant, Q. This constant here is the electrochemical equivalent. And you could remember that quantity of electricity or charge is equal to current times time. And if that is so, therefore I will have the mass of the substance to be ZIT. Take this equation as the first equation, which can give you any question that regards with the mass of the substance, the current, and the what? Time. Now, when you make Z the subject, here I will have mass over current times time. Now, what is electrochemical equivalent? The electrochemical equivalent is the mass deposited when 1 ampere of current passes through 1 second. You get what I mean? When 1 ampere of current passes through what? 1 second. We have what? The electrochemical what? Equivalent. Therefore, the electrochemical equivalent can give me 1, which is equal to the what? Mass. When you subject this to be equal to say 1, current being 1, time being 1, that means I will have it to be this to be equal to M. And if this can hold, you could also recall or have it that 1 Faraday constant is equal to 96,500 coulombs. Now, when we come to metals and non-metals deposited in the cathode and the anode of the electrodes, now it means that to deposit a potassium ion, there will be presence of what? 1 electron charge to give what? To give potassium atom. That means 1 farad of potassium ion will deposit 1 electron, 1 positive electron. And in the same way, when you talk about the calcium, it means that 2 farad of calcium will deposit 2 positive electrons of calcium. And in the same way, for aluminium, I will have 3 farad of aluminium, which is 3 plus, to give what? 3 electrons. Now, if this can hold, it means that the molar mass of this substance gives the valence charge, which is this 1. Yes, the valence charge times Faraday constant. If This can hold. Remember, I'm doing all this in order to achieve the almighty formula or the general formula that can give you your answer. Now, can I divide the both side by CF? Dividing the both side, I will have this and this to be what? 1. Therefore, I will have this to be 1 to be equal to molar mass. Molar mass of the substance deposited over valence charge times Faraday constant. But now, remember I said that the electrochemical equivalent is equal to 1. That means my Z can be equal to molar mass over charge, valence charge, times Faraday constant. Then if this can hold, if this statement can hold, and this statement can hold, can I equate the both of them? Equating the both of them, this will imply that mass of the substance over current times time will be equal to the molar mass over charge, valence charge times what? Faraday constant. And when we have this, I can decide to take ratio. Taking ratios, this will imply to have mass over molar mass of that substance deposited to be equal to, this one will go the other side, this one will come down, we'll have current times time over valence charge times Faraday constant. At this point, having this formula is my first equation, my first almighty formula that can give you solution to any calculation question regarding to Faraday first law of electrolysis. But furthermore, you could also know that since charge is equal to current times time, I can write this formula again to have mass over molar mass to be equal to this current times time will now be what? Quantity of charge deposited during the electrolysis over what? Valence charge times Faraday constant. This gives me what? Equation 3. Then also, do you recall number of mole is equal to mass over molar mass? Yes. And if this can hold, I will have it to be mass over molar mass will now be what? Number of mole to be equal to what? Charge over valence charge, Faraday constant. As this gives equation 4. So now, having these 4 equations, 1, 2, 3, 4 only, can give you or solve any question that regards to Faraday's first law of electrolysis. So, take your time, share this video to your loved ones, and don't forget to subscribe for more videos.